This is a video for MEI Core Pure Mathematics, Vectors 5, Further Lines and Planes, 5.1, the vector product. There's more than one way to combine two vectors as a product, and we've already met the scalar product of two vectors, which we write like this, A dot B. And in fact, we sometimes refer to this as the dot product. We can also look at the vector product, and we use a cross symbol for this, A cross B, and sometimes we refer to this as the cross product. Now, unlike dot product, the cross product is only for vectors in 3D. We can do the dot product for 2D vectors, but we can only do a cross product with 3D vectors. So here's the formula for the definition for the cross product. So we've got A cross B here, and if we think of them having components A1, A2, A3 and B1, B2, B3, then this formula gives us the result. So for the X component here, it's formed from doing A2 times B3 minus A3 times B2. For the Y component, we've done A3 times B1 minus A1 times B3, and for the Z component, we've done A1 B2 minus A2 B1. So if we have a look at this example and calculate this cross product, for the X component I'll do 3 2s are 6, take away 8. For the Y component we'll do 6 take away 2, and for the Z component we'll do 4 take away 9. So we'll get minus 2, 4, minus 5. Now notice the result is a vector, and hence this is sometimes called the vector product. And from here you can see that this thing has both magnitude and direction. And we'll have a look at this in much more detail in subsequent videos. So let's think about this example. I've got here a cross product which I'm told the result of, and I'm missing one of its components here. So I've got 3k1 cross minus 2, 0, 4, and I'm told that that's equal to 12 minus 14, 6. Well, if I start to do the cross product, I'm going to get 4k minus nothing, so I'll get 4k for the top. I'll get minus 2 take away 12, so I'll get minus 14 for the middle. And for the bottom one, I'm going to get nothing take away minus 2k, so I'll get 2k. And as I said, I know that that is 12 minus 14, 6. And so it doesn't matter whether I use this component, the first component, or the third component. From the top one, I'm going to get 4k equals 12, which means k equals 3. And from the bottom one, I'm going to get 2k equals 6, which also means k equals 3. Now, we've included the formula for the cross product up here on this slide. You don't need to memorize it. It will be in your formula book, but it is important that you know how to apply it and that you apply it correctly. So there's the results for that. If you use the first term, you get 4k equals 12, as we saw before, and therefore k equals 3. Or you could use the third term and you get 2k equals 6. So again, you get k equals 3. Now, we've already seen that formula already, although you may not recognize it. But if you have studied matrices and determinants, you'll see that actually the cross product can be written as a determinant like this, and then if we do the expansion about the first column, we end up with the cross product. So this works out like this. If I think about the I bit, I'll get I times A2B3 minus A3B2, and then I'll get minus J times A1B3 minus A3B1, and finally plus K times A1B2 minus A2B1. And if I write that as a column, I get A2B3 minus A3B2. And then for the middle one, this minus sign will flip this round, so it's A3B1 minus A1B3, and finally A1B2 minus A2B1. And you'll see that those two are actually the same. Now this notation here can be easier to remember if you're familiar with determinants. A couple of examples, and we've got the determinant formula here, so let's try these with that. So I'm going to get I, J, and K. 1 minus 3, 4, 3, 2, minus 1, and then if I plug those in and expand, I'll get 3 take away 8 is minus 5, and then minus J times minus 1 take away 12 is minus 13, plus K times 2 take away minus 9 is 11. So that gives me minus 5I plus 13J plus 11K. And if I write that as a column vector, that's going to be minus 5, 13, and 11. Here, same thing, I, J, and K. Plug in the vectors 3, 2, minus 1, and 1, minus 3, 4. And then work that through, so I times 8 take away 3 is 5, minus J times 12 take away minus 1 is 13, plus K minus 9 take away 2 is minus 11. So that gives me 5I minus 13J minus 11K. And again, I can write that as a column vector, 5 minus 13 minus 11. And notice that I've got the same answer from these two, but one is minus the other. And if you look at these two vectors, if I call that A, then this is A. And if I call that B, then this is B. So I've got B cross A is minus A cross B. And it turns out that this idea we will see again when we look at perpendicular vectors. There's the write-up for that. Here you've got confirmation that they are simply a change of sign here. This vector here minus it, you get this vector here. Many calculators have a facility to deal with vector operations, and if yours does, then use this example and see if you can get the right answer. You might want to pause at this point before we reveal what the answer is. And what you should get from your calculator is 21 minus 6 minus 8. The next video in this sequence is 5.2 using the vector product.